So kind of similar to what we've done before, except now you're changing a complex number to polar form. And the polar form, a plus bi, is going to go to the polar form r cosine theta plus I sine of theta, which I abbreviate to be cis. Cosine, I sine. I took each of the one respective there. The r is found like we did last, I guess it was 3 days ago, something like that, where it was the square root of x squared plus y squared, only now it's a and b. It's the same principle though. Theta is found by taking the arctangent of the b divided by the a. If a is negative, you add 180. And I said up here, use exact values whenever you can. If it's a 30, a 45, a 60, you should be using like the radical 3's over 2's whenever you're doing that value. Then the second half, r cis theta, and I didn't write it out, but that means what? R cosine of theta plus I sine of theta is equal to a plus bi. All you got to do is distribute. So your calculator, though, you want to make sure your calculator's in the correct mode, because there's rads and there's degrees, and you're going to use them both.
So you just distribute the radian?
You'll take the r that's on the outside times the cosine of the theta times the I times the sine. You don't add it, because one has an I.
Can you change modes in the middle of an equation?
You'll change it at the beginning of your problem, which we'll go over that when we get to that. Okay,
good.
so let's go over the 26 through 34 first. We're changing a plus bi to r cis theta. So if I were to have, let's go 4i. Now 4i really means that I have 0 plus 4i. Everybody agree that that's true? There's not an a, so we put the 0 there so it's understood. We want to change it, so what's the formula we use? R equals a squared plus b squared. So it should be 4. This is the a, this is the b. So a squared plus b squared under your square root of r. Now, theta, you guys need your calculators. Arc tangent.
So we don't do 4i, we just do 4?
4. R is just 4. The I comes on the next part. Arctangent of b divided by a. Now, this is like before.
It's undefined.
It's undefined. Your calculator can't do it for you. That's ones you have to know. So where's the tangent undefined? There's 2 places.
270 and 90.
Okay, if you see a positive involved, you're going to take 90. If you see a negative number involved, you're going to take 270. So this answer is going to be which one?
90.
Because 4 is positive. So my answer then here is 4 cis 90.
Can you? Why is it positive again?
Because it was a positive 4. If that had been a negative 4, then I would have taken 270. Does everybody follow what I'm saying there? There's 2 places where the tangent is undefined. 90 and 270. Okay, what if I have negative 6? I'm doing all the ones that are unusual first, and then we'll do some that are got both a and b. So this will be rewritten as negative 6 plus 0i, right? Because I don't have an I terms. Everybody understand that process?
Yeah.
Okay, so r is going to equal the square root of a squared plus b squared. So that would be 6. Now what about my theta? How do we find theta? The arctangent. So my b is 0 over negative 6. Did you notice that this was negative? What's it say when b is negative? Add 180. But what's 0 divided by anything?
B is 1. That B was positive.
If a is negative, you got to add 180.
Okay.
If a is negative. The b is 0 right now.
Oh, okay.
So 0 divided by negative 6 is 0. So tangent of 0 is 0, isn't it? In that one that you should know.
So we don't have to add 180?
You do add 180. Why do I add 180?
Oh, because you added it after.
Anytime the a is negative, there's no, if it's negative, ever, anytime you see that very first term is negative, you're going to add 180 no matter what. So this ends up being 180. So the answer for this one is 6 cis 180. Now, do you guys have your calculators handy?
Yeah.
Okay, this one's an easy one to check. You can check every one of these. Remember to go go backwards, you use distributive property. Take 6 times the cosine of 180, see what you get.
Is our final answer
Negative
supposed to be
6.
6 cis of 180? What about the top of what would it be? 4 cis?
I got it blocked. What did you get?
Negative 6.
Negative 6. What's 6 times the sine of 180? Should get 0.
Yeah.
And see, doesn't it match? You can check every answer by distributing. If you distribute, you should get back what you started with. Okay? Next.
Could you write that out as the wrong way?
You can write it the long way. And you'll probably see if you look in the back of the book, it'll say 6 cosine of 180 plus I sine of 180, which to me, that's a lot of writing when you know what it stands for. Cosine I sine. Okay, now I'm going to add numbers in both positions. Let's go 2 plus 5i. We did all the specialties first. So 2 plus 5i, I want to find r. So let's see, Taylor, what would my r be?
Square root of 2 plus square root of 5, so 4, 25.
So 29? Okay. Theta, how would I set it up, JC?
10, 2
The other way around.
over
B over A.
5,
Do I add 180 this time? No. So everybody go to your calculator. You're going to take second tangent, 5 divided by 2 degrees, minutes, seconds.
6812.
6812, anybody else? Yep. So my answer then is written, square root of 29, cis of 6812. And again, I'll repeat, if you prefer to write it out the long way, you can. Square root of 29 cosine of 6812 plus I sine of 6812, and it means the same thing.
So, like, the I doesn't really matter when we do these.
Yeah, I's always going to go with the sine term. That's why I got I with the S.
But it doesn't, like, change anything.
It just means you won't be able to add them together, because one has an I with it, and the other one's like that. See, right here, I can't add those together. Let's go negative 5 minus 7i. Okay, so Mason, find the r. What would I do?
It'd be negative 5 squared, and then plus negative 7 squared. Square root of 74.
Okay. Theta, how would I set it up? Tara?
Arctan of -7 over -5, but you need to add 180.
You add 180 before you hit degrees, minutes, seconds, right?
Yeah.
That way you don't have to do it twice. So you do this part first, and then do DMS. Okay, so to your calculators. Second tangent of -7 divided by -5.
Doesn't matter if they're both negative.
2 negatives is going to make a positive, so that's really not going to matter if you didn't want to put it in. Then add 180. We have to add 180 because this one was negative.
234, 28.
234,
28. You have to count that too.
28. Sound like we got a couple agreeing? So our answer would be written, how could I write this?
It would be square root of 74 cis of 234 degrees 28 minutes.
And now, what if you wanted to check your answer?
You would do.
Take the square root of 74 times the cosine of 234/28. Somebody do that and see if you get 5.
Why, when we check it, why do we only multiply it by the cosine?
You do both.
Oh.
See, it's square root of 74 times the cosine, and then square root of 74 times the sine. See, that's cosine plus I sine.
Yeah.
I'm not sure.
Yep, -5.
Did you get a -5? Now what
Yeah,
about
that's
square root of
right.
74 times the sine of 234/28?
So you're saying if one of them works, then the other one probably works as well?
Probably.
Okay. I
I'm just
see.
saying, you could do something real quick.
I see.
Did you get a -7?
I got -4.99.
That's close enough, see, because we rounded, so that's where you can have error. Anybody try the 7? See if we got it?
Yeah.
And square root of 74 times the sine of 234/28. No?
-7, yes.
-7? Okay. Let's do 1 plus I. 1 plus I. So, White, what would I do to find R?
Take the square root of 1 squared plus 1 squared.
Right. So that would be the square root of 2. Okay? Dalton, what would you do to find the theta?
Root 2 arc tan 1 over 1, and that would be 1.
So we should know that one. That's 45 degrees, isn't it? Isn't that one of our values? So we'd have the square root of 2 cis of 45. Is everybody agreeable there? And again, if you wanted to check, what's the square root of 2 times the cosine of 45 and see if it ends up being 1. So what I'm telling you is you don't have to miss any of these. You can double check them all. Okay, that's 26 through 34. So what do you think 35 through 42 is?
They're going opposite way.
Right.
Yeah.
35 through 42, examples for it, you're going from r cis theta to a plus bi form. And all you really got to do is distribute it and use your calculator. But I'm going to try to make sure that you know how to use your calculator. Let's see, White, do you have a calculator? You might want to make sure you have one, because we're going to change the modes.
Okay.
Pass that back.
Oh,
Let's do one that is in degrees first. Let's say I've got 2, and now the book is going to write it cosine of 30 plus I sine of 30, right?
Yes.
How will I write it?
This is 2 cis of 30.
This one, you should be able to do on your trig chart. You really don't need a calculator on this one. We should know what the cosine of 30 is. What is the cosine of 30? Square root of 3 over 2. So 2 times the square root of 3 over 2. Okay, now what's the sine of 30?
Sine of 30?
1
Is that
half.
1?
1/2. So this ends up being the square root of 3 plus 1i, which do I have to put the 1?
No. It would be square root of 3 plus I.
Now, let's try it with our calculators. We did it using what you should know of the common trigs, the 30, the 45, the 60. Now, put 2, your calculator's in degrees, I did one with degrees. What's 2 times the cosine of 30?
1.772.
No, you'd say 1.73, because I want it rounded nearest
Yeah,
10.
1.73, yeah.
Okay, and isn't the square root of 3 1.73?
Yeah.
So we just approximated it. What's 2 times the sine of 30? Do that on the calculator.
1. Where did,
So we got the same thing.
Mhm.
But if it's exact, I already told you earlier, I want you to use exact answers whenever possible. So I prefer the square root of 3, because it is an exact answer.
so whenever we wrote 2 square root of 3 over 2 plus 2 times 1 over 2, we just didn't write the I next to it?
Yeah, I just didn't put it there. You can put it there if it helps.
Okay.
Okay, next one. Let's do 2 cosine of 5, and this is the one where we need our calculator, because what's my 5 there? It's not in degrees, I didn't put a degree symbol, so that means it's in, no, it's in rads. A real number is rads, so you need to make sure your calculator is changed to rads. How do you know when it's in rads?
It'll say on the bottom.
It'll say down on the bottom or up at the top, depending on your calculator, but you hit the DRG key, and you change it to where it says rad by moving your arrow key there and hit enter. So yours says rads now. Everybody got theirs where it says rad?
Backwards calculator, you just.
You still do the same thing, you gotta make it in terms of rads,
Okay.
got it? Now, we're gonna put it in our calculator. So the only problem that I've seen students doing it this way, changing it, instead of changing this to degrees, is sometimes people forget to change their calculator back to degrees. So be careful when you go back and forth. So what's 2 times the cosine of 5? So Delaney, on yours, you'd go 5 cosine times 2.
It's 0.5657.
.5657, so I'm gonna make it .57.
Yes, it's
Yeah.
rounding.
Okay, now what's 2 times the sine of 5? And that's the one I'm gonna add the I on it. Negative what?
Negative 1.9.
Maybe 1.92.
Negative 1.92
How did,
So
for the second part, we did 2 times what?
sine.
That's right,
See,
100.
the cosine we did first, then
Okay.
you do the sine.
Yeah,
We don't-
do it on
okay.
5.7.
Yes, you did, because 0.56, you wanted 0.57.
It was .56 something, and I rounded it up.
Yeah.
I didn't write it all. I think it was 567 something.
Yeah.
So we don't round the second one?
Yeah, we rounded it too already.
Yeah.
At least I hope you guys
Yeah, we
did.
did.
Yeah, because that's the second one.
0.4.
Did yours not work?
Okay, I got you. I was confused because there's 3 numbers, but 2 of them were behind the next one.
Okay, are we okay with that? Changing grads? Let's do one more grads. Let's go on 3, and this time it's gonna be the cis of 2.5. Still that's rads, because there's not a degree symbol. So you make sure your calculator says rads in the window. And now what's 2 times the cosine of 2.5? Negative 2.40.
Why are we times it by 2?
That's-
3 times 3.
Okay.
3 times the cosine of 2.5. That's so different?
I got negative
Yeah.
2.4.
Okay, everybody try. Are you in rads?
Yes.
Yeah.
Yes, yeah, they're right.
Negative 2.40.
Negative 2.40.
Yeah, I did it again.
Where'd you get it, Ellen?
I'm still getting 1.7.
Don't you have a backwards calculator?
Yeah, you
Did
just
you get
write,
something wrong?
just put 2.5 cosine
I'm doing
equals
that.
times by 3.
Are you in rads?
Oh, I'm multiplying by 2.
Oh, there you go.
That's
Okay,
what I
next one.
did first.
What's 3 times the sine of 2.5?
1.795.
1.795.
That's what that was.
So that makes that to 1.8.
Yeah.
Does everybody concur with that one? Now I'm gonna give you one to think about. Let's go with 6 cosine of 5 pi over 4 plus I sine of 5 pi over 4, which could be rewritten the cis form, right? You have an option. What's your option?
Converting it to.
You could convert it to degrees, because that doesn't take much to convert it, or
Just leave it.
leave your calculator in rads and you're gonna go 5 times pi divided by 4. Does everybody follow what I'm saying?
What?
You have 2 options. One, you've been doing this for the whole chapter, changing rads to degrees, so you could
Right.
multiply this by 180 over pi and make it degrees. The other option, since you've got your calculator in rads, is just to go 5 times pi divided by 4 when you put it in. So I thought we'd do it both ways. So first, if I changed it to degrees, and that happens to be 45 degrees, so it's third quadrant, so that would be radical 2 over 2 times 6, and it'd be negative, so it'd be negative 3 square root
How'd
of
you
2.
get that?
How are you getting 45 degrees?
225 is the reference angle is 45 degrees, because you subtract 180. Remember when you did that?
Uh-huh. Yeah.
So, and it's in the third quadrant, so that makes it negative. Now, if you did your calculator, what did you get when you put it in rads?
Negative 4.24, and then it would be minus negative 4.24, and then
Now, what could we do to double check that it's the same? Take 3 times the square root of 2, see if that's the 4.24.
Do we have to do?
I'm saying check it, just to see.
No, but do we have to do the 45 degrees instead of?
You should do an exact answer whenever you can, which that one's the one we know, 45 degrees. You should know your 30, your 45, and your 60-degree angles. Okay, does everybody follow what I'm saying? You can do it this way works both.
Okay.
Is this the same? Has anybody checked it?
Yes.
Okay,
I
so
got the same as
You got the same thing. So you can either keep this in rads, or you can switch it to degrees, whichever you prefer, which I don't think they have very many that you have to, I think most of the rads are like this. So you're gonna round to the nearest hundreds in most things. Okay, do you guys have questions? You want another example? Okay, then JC, I probably need to go over with you, and who's the other one that was gone yesterday? Wyatt, what we did.